Alrighty, let's get started. Can you guys hear me?
Yes, we can.
Yes.
Wonderful. Thank you. Okay, well, let's start where we left off. So we're basically talking about just how Looker writes SQL on the fly. We'll just talk about that. So, when it comes to any Explorer, there's always a base view. The base view is the table that you bring in first, mostly the fact table. Within any query of that Explorer, that base view is always going to be joined in. It's always going to be the table after the from clause. However, with all the other joined views in the Explorer definition, those will only get joined in if one of its fields is being used. So that's a major difference between the base view and then all the other views. So when it comes to filters, if you filter on a dimension, it's always going to show up in a where clause. If you filter on a measure, say where total sales is greater than 100, that's always going to show up in a having clause. So, a where clause, let's just talk about a having clause. A having clause is, after aggregation takes place, it runs a filter on a measure, on a metric, whereas a where statement, it's pre-aggregation. It happens right off the bat. It'll take out any values where the dimension isn't defined. Also, you need to keep in mind is row limit. SQL or Looker typically has row limit set on its explorers. When you're in the Explorer realm and you're building a visualization, usually the max is 500. It can go up to 5,000. It can't go up any higher than that, unfortunately. Let's talk about creating dimensions and measures. So just remember, a dimension is a quality or attribute of your data. Your model will always contain a dimension for every column in the database table. Whether it's a dimension or a measure, every field is going to have a dimension created off of it. When you create a dimension off of a field in the table, you're going to see this table syntax as you see in red right here. This means it's directly accessing a table element. So for the dimension sale price, it's grabbing field sale price from the table. Now, if we scroll to this measure right below it, total revenue, you see it doesn't have a table statement. It's not directly referencing a field in the table. It's actually referencing a dimension in Looker, sale price, which is right above. So for that reason, it's not referencing that table. This is typically how you want to do it. When it comes to, first creating a view, Looker will already create a dimension off of every field and use this table syntax. Thereafter, whether you create dimensions or measures, you shouldn't be using the table syntax. You should be referencing other Looker elements, whether they be dimensions or measures. And that has the syntax of what you see for total revenue in the SQL statement. There's no table statement. So just to reiterate, this is the other way of referencing a field where you don't, reference it directly. You reference it as it's an element. it's a looker field already. So sale price, since it's already defined as a dimension, when you reference it, you just use this syntax. So we'll talk about dimension types. There's basically two main types of dimensions or dimension types: type string and type number. Um, anytime in your database it's a varchar, a char, or a text, that's just substituted in Looker as a string. Anytime you have a dimension as a number, that would be of type number. So this is a good example. Days since sign up. That is a number, but it's something that you're not going to aggregate on. It's something you're going to slice and dice on. So it's going to be treated as a dimension, even though it's a number. On to some more types of dimensions. Type yes, no is basically true, false. Um, in the SQL statement, you just apply what's the true statement. So in this example, for is new customer, they're deemed a new customer if days since sign up is less than or equal to 90. So as you can see, the SQL statement just supplies what makes the statement true, and then all else will be false. And that's of type yes, no. It shows up in Looker as capital yes and capital no rather than true or false. Tier is another good example of a dimension type. This is when you want to take typically a number, in this example, days since sign up, and you want to bucket it into tiers. Um, this is definitely useful for some sorts of analysis, most notably if you're trying to create a histogram. So you take the metric and you bucket it into tiers, and when you use a tier dimension, the different levels will be 0, 30, 90, 180. So that's a nice way to analyze a metric. Uh, Behind the scenes, both of these types of statements are going to produce case when statements in SQL. Now for date fields, for time fields, there's a dimension group called of type time. This is very valuable in that it saves a lot of code. You plug in the date field as you see in the SQL statement, and then within the time frame statements, there's tons of options, but you put in all of the ways of which you want to aggregate the data, whether you want to do it by time, by date, by hour, by month, by year, by quarter. You just supplement all the different scenarios in the time frames part, and you'll have the option to aggregate by such fields. There's another type of dimension group other than the date dimension group, which is of duration. This is a really cool one. So this example is enrolled, and what you put in is the SQL start and the SQL end statement. So in this syntax, we're making the start field enrollment date and the end field graduation date, and it's going to calculate the interval between these two fields, and you supply the intervals of which you want to see it by, whether it be second, minute, hour, day, week. This is a very useful field. I typically use days since today, just to see how far in the past a date is. So for the SQL end, I just supply the current date function, and then that will always tell me how old a date is. We're going to skip the exercises. We don't have time for that. All right, now we're going to talk about measures. Measures is what perform aggregate functions in SQL. So for the most part, a measure just points to one or more existing looker dimensions in a SQL parameter, and it just defines a way to aggregate it. The most common ways to aggregate is by sum, average, count, and count distinct. So when you're defining a measure, let's start from the top. You see a dimension called cost. This is like a raw field in the table, even though it's a metric. It first gets defined as a dimension. That's how all fields are created in Looker. And then afterwards, in order to actually turn it into an aggregate, you create a measure off of it. So in this next example, we're calculating a measure called total cost, and you plug in for type what type of aggregation you want, whether that be sum, average, count distinct. And in the SQL statement, you're referencing the dimension field cost. So now this total cost measure is always going to aggregate field cost. And then the same goes for average, as you see down below. Other ones would be count and count distinct. So count, you don't see it referencing a field. It basically just counts the row count of the table. And then count distinct is the unique values, the number of unique values for a particular field. So the count of users is just going to count distinct the unique number of user IDs. All right, let's talk about some advanced logic on dimensions and measures. Adding a filter to a measure is very valuable, very useful. There's a filters parameter in Looker, as you can see in red right here. So if you want to have a filtered measure, you just use the filter statement. The syntax is kind of weird, but first you reference the field of which you want to filter on, and then you enter the value in double quotes. Down below, this is of a type yes, no field that's being filtered is new user. And you see how it's referenced capital yes. It's not true, it's yes. I made that distinction earlier, that yes, no fields are not true, false. They are true, false, but in Looker, they're referenced by yes and no. When it comes to like percentages, there's many scenarios where you want to use a measure with other measures. You create a measure that's based off of other measures. So in this scenario, since this measure is created off other measures, the aggregation has already taken place in the preceding measures. So in order to calculate like a percentage in this scenario, the percentage of female users, the type is of type number. It's not sum, it's not average, it's got to be of type number. Anytime you're referencing another measure, you got to make sure it's type number. And then in the SQL statement, you plug in the measures that you already defined in this scenario, count female users and count. And this will calculate the percentage correctly. So this is definitely has many use cases. Obviously you put percentages all over the place. Anytime you got to create a percentage measure. It's going to be of type number. You got to reference the measures in the SQL statement. The value format name parameter, that's definitely my favorite parameter to use. There's another one just called value format, but value format name is just lets you put in the right format for a measure. It can be percent, and then the one represents how many decimal places. So percent underscore one is a percentage with one decimal place. Percent underscore zero would be 0 decimal places. The other more common one is US dollars, and that could either have 0 or 2 decimal places. And then just simple decimal underscore 0 would be just an integer. This is a very important example. Sometimes when you're creating a dimension or a measure, you're going to be referencing a dimension that's from another table. So whenever you're going to reference a dimension from another table, you got to make sure you supply the two-part reference of the field. You have to reference what table it's from, and then the measure itself. Another caveat, you got to make sure that there is an explore definition created that joins in this item inventory items table into the explore, or else this will produce a syntax error. So, you got to be careful when you're doing this. You need to make sure that you have all explorers using this as the base view have this inventory items dimension table joined into it, or else it produces an error. But just so you have the ability to crisscross tables and their references in Looker. And then anytime you're going to be referencing a measure that's from a different table, you just got to supply what view it's coming from. All right, let's talk about some helpful field parameters. These are, other parameters that you can put inside of a dimension or a measure. It really helps clean up the Explorer. First one is hidden. So, for instance, like the primary key of a table, not really useful for analysis. It's just more useful behind the scenes and for, symmetric aggregation. Anytime you just want to hide a field from the Explore pane and disallow a user from even using it, there's just a hidden parameter. You just put hidden equals yes, and that will hide the parameter. Label will actually change how a field name will appear in the field picker. So if for example, a field is called zip, ZIP for zip code, that would be all caps. ZIP is all caps. You would need to format that in the label to make sure that it shows up in all caps. So basically the label just changes how the field name will appear. Group label will combine fields into custom groups within the view of the field picker. So just for organization purposes within the Explorer, if you want particular fields to be grouped together, then you would use the group label. Description is displays additional information about a field once upon hovering. So in the Explore pane, if you apply a description field to it, as you hover over it, it's going to give you a nice description of what the field is. Value format name, what we already talked about, decimal 0, percent 0, USD 0. It just puts a format on the field to show, how you want it to be displayed. Drill fields, you can put on any dimension or measure, which it it will allow you to click into it. And so, for instance, in a dashboard, if you got total sales, if you want to drill into total sales to see what data represents that number, you can apply drill fields, and you just enter in the field names, and then it will do a drill functionality to show you kind of what's under the hood of a particular data element. All right, let's talk about model files. We've basically been talking about view files with all of the dimension and measure attributes that we were talking about. Now let's talk about the model file. So explorers are a set of tables with a predefined join logic. Here's an example of an explore definition. So it starts off with the parameter explore, and then you enter in the base table. In this scenario, it would be inventory items. That's typically the fact table of the explorer. And then to join in other tables into the explorer, you use the join parameter. So in this scenario, we're joining in the products table. And there's 3 parameters with the join, with a join: type, SQL on, and relationship. It's very important you get all this right. In order to get it right, you might have to do some data investigation to check the primary keys of the tables of which you're joining, just to make sure you got the right types and the relationship. For type, you can either be left outer, inner, full outer, and cross. For relationship, and it can either be many to one, one to one, or many to many. And then the SQL on parameter is the exact join logic that will join the 2 tables together. So just to say it again, the SQL on parameter is the field that should be used within the on clause of the SQL query in order to join the 2 tables together. And relationship is how the 2 tables relate to each other. So again, just to reiterate, pay attention to what the base view is. The base view is the first field that is represented in the Explorer. In this scenario, it's flights. And then all the other tables that get joined to it are just basic, joins. The base view is always going to be a part of the SQL statement in any query, whereas the joined tables will only be represented if one of its fields is being represented in the results. Sometimes we need to join the same table twice into an Explorer. And in this example, there's a table called airports, and it's going to be used in 2 ways: for the origin and for the destination of the aircraft. So when we're referencing the same table twice, that's when you use the from parameter, as you see below here. In the join statement, you give it a name, any name you want as to what you want it to appear in the Explore definition, but then you put the from parameter in to reference the exact table name that you're using. So in this example, in the from parameter, you see the same table airports being joined in twice, but this all works out just fine because since they got 2 different aliases, aircraft origin and aircraft destination, This is how you join in the same table twice. It's by using the from parameter. So here's just an example SQL query built off of this Explorer right here. This is what happens behind the scenes. This is what LookML does. It creates SQL on the fly. Um, as you can see here, flights would be the the base view of the Explorer, and then airports and aircraft are the dimension tables that are being joined in. And the only reason why they're being joined in is because they're being used as fields in the select statement or potentially in the filter statement. Anytime anything from airports is being used in the query, it's going to force that table to be joined in. Otherwise, it won't be joined in. So this query right here translates into this explore definition. And just like there were some helpful parameters for view files, there are some helpful parameters for explore definitions. First one being the label parameter. This will change how an Explorer name will appear. A description. So upon hover, if you want to give a description about what the data model is, what the Explorer definition is, you can do that in the description. View label will change the label of the view within the field picker in the Explorer. Group label will combine Explorers into custom groups within the Explorer dropdown. And fields will limit the scope of fields that are available in the Explorer. So if you only want to show a particular set of fields in an Explorer, you can define that using the fields parameter. Okay, let's talk about a very complicated topic, but really a game changer with Looker. It's an awesome feature. You don't have to do a single thing for it to be turned on. It just solves a very common database problem that has been around since the 70s, since databases have existed. Once I explain it to you, I hope you understand uh, what is known as the fan out problem. What is the fan out problem? So, imagine you have two tables, customers and orders like you have here. The customers table stores customer data such as customer ID, first name, last name, and the number of visits they have made to the e-commerce platform. The orders table stores order data such as order ID, the amount of the order, and the ID. The relationship between the tables is one to many because a customer can make multiple orders, but each order can only be made by a single customer. When considering these tables individually, the count in some operations produce accurate results. There are 3 total customers, 3 total orders, 8 total visits, 4 total orders, and $250 in total orders spent. So we need to join these two tables in an Explorer so that business users can analyze the data across them both. It is pretty clear that the customer ID should be the join key. However, when we join these two tables together on customer ID, given the one-to-many relationship, we actually produce what is called a fan out. So this table illustrates the result of the many-to-one join um, from previous, and you can see that it fans out the customer's dimension. It introduces a duplicate row for customer one because Amelia Earnhardt made more than one order. When performing aggregations on the customer side of the table, we now get incorrect results. The sum of the visits will equal 10, whereas when we look at the table, we know that one of the twos is a duplicate. So for visits, if I go back to the raw data, for visits, you see a total of 8. But if you perform this join, you're going to duplicate a row, and now you're going to see 10 visits, and that's not the right result. This is what is known as fan out, and it's a common database problem. Common, just if you're working with databases in SQL, you're running this issue all the time. You got to be careful about not duplicating metric values and to produce erroneous results. This is not a new problem that Looker has found, or it's not Looker specific. This is database. Ever since databases has existed, this has always been a problem. So with symmetric aggregation, as long as you supply the correct primary keys of each table and you correctly specify the relationship parameter, it's going to know when a fan out exists, when a duplicate row is going to get created, and it accounts for that. It will produce the correct results on the fly. We'll show you how that happens. So just to reiterate, primary keys are of pivotal importance for any view definition. Always make sure that you have the correct primary key defined within any view. It's extremely important for symmetric aggregation to work correctly. To test the primary key, you can just create an explorer off of the view that you created, plug in the number of rows, and then take the count distinct of the primary key field of which you created and see if those numbers are exact. If they are exact, that means you have the right primary key. If they're not exact, then you don't have it, and you got to make sure that you do figure out the primary key. Usually a primary key is the unique combination of a certain number of fields in a table. Just make sure that you run the test to make sure that with the primary key defined, it is unique across the table. This is just walking through what happens if you don't define the relationship correctly. You get erroneous results. I think this is what I want to show you. This code right here, this is symmetric aggregation at play. It looks very intimidating. Nobody really understands what's going on, but rest assured, this is symmetric aggregation taking place. If you see the MD5 function, that lets you know that symmetric aggregation is happening. What basically happens is, to get to the right metric number when fan out exists, it takes an extremely large integer, multiplies it into the function, and then multiplies it back out. I don't fully understand exactly how it works, but rest assured it works. You need to understand this is nothing you need to do on your end. This is automatically set up in Looker to exist and to work. It will work correctly as long as you have the primary key set and the correct join relationships created in your Explore definition. Let's talk about filtering explores. There's, three tiers of ways to filter on an Explorer. Um, the first two easy ways are using a SQL always where and a SQL always having statement. That is, the basic way to filter out an Explorer, whether it be on a dimension or a measure. If it's on a dimension, you use SQL always where. If it's on a measure, it's SQL always having. And I'll talk about the other two later. So you want to use the SQL always where and the SQL always having when you have some immutable logic. Immutable meaning that you don't want the end user to ever be able to change this filter. It's the basic way to filter out and explore. Most commonly used. You just plug in. Let's see if we get an example. There's an example. So if you add the SQL always where statement here up top, we're filtering on a date field where the created date is greater than equal to 2020 2012, and it's pretty simple what this will do. It just adds a where statement to every single SQL that gets generated off of this Explorer. And then with the SQL always having, that will be off of a measure. That will just add a having statement to every single Explorer SQL definition. Here's an example of how to add a filter on two fields uh, by status and by country. You just have a comma in between them, um, and that will produce an and statement to say where status equals complete and country equals USA. Oh, let's talk about the always filter. So yeah, the always filter, unlike the SQL always where and the SQL always having, this adds a filter to the Explorer front end. It has the word required under it. So although users can change the filter operator and value, they cannot remove the filter itself. So if you want to force a field for filtering on an Explorer, you use the always filter. This will force the user to have to use this filter, but however, they have the option to change the value of the filter. The last type of filter is called the conditionally filter. It's it's the same as the always filter in that it adds a filter to the Explore front end, but it has the words conditionally required under it. So although users can change the filter operator in values, they cannot remove the filter unless itself, unless they put a filter on the specific alternate field. Um, so in this example, the filter is where created date equals 1 month, and that will be forced to be used unless the user specifies a user ID or a user state filter. This is typically used when the data is very large and you don't want users to produce really big, expensive queries, and you force a smaller query by forcing a filter on the data. Um, that's what the conditionally filter is usually used for. It's used to save query costs. Give me one moment, please. I need to pull up a new deck. All right, let's talk about caching and data groups. Caching is a very useful feature that reduces database load and helps to optimize Looker performance. Um, Persistent derived tables is like the key word when it comes to caching and data groups. So, um, typically SQL or Looker will generate SQL on the fly to your database. Sometimes you want to persist that table so that it loads up right away and not have to be derived on the fly. And the way to create a PDT is through creating data groups. So caching uses saved results from prior queries so that not every query needs to be run on the database repeatedly. This helps to reduce database load. A data group is a Looker term for a caching policy or rule. Whenever someone runs a query in Looker, the SQL and its results are stored in an encrypted file on the Looker instance. That's how caching works. So if you got caching on a particular explore or derived table, um, Looker will first run a query to check whether the same exact query has resulted from the run before. And if that's the case, then it's going to just use the pre-existing cached query that uh, the database has saved off. However, if something's changed, then it will regenerate the query on the fly for you and produce fresh results. So this is how caching comes into play. I just want to show you the way it works. You define a data group, and you can see it in this example below. Um, there's two parameters, and you typically want to use both of them. They kind of work as backups to each other. Both of them get checked. The first one being the max cache age, 24 hours. That basically says if the cache is 24 hours or greater, then regenerate it. And then the SQL trigger, this one is very important. This one will just run a small, simple query on the table. Typically every 5 minutes, I think it runs this query. And if there's a change in the results, so this query is just a run one row, one field result, just calculating the max ID. This will get tested every 5 minutes. And if this changes, that will be a trigger to regenerate the PDT. And typically you want to use both of them. They're not required, but they kind of both work together as a fail-safe. After defining a data group, then you apply the data group to an explorer just by using the persist with statement. So if the data group is called order items, then you use the persist statement, and then you just plug in what the data group is, and that's just how you implement caching up or a PDT inside of an explorer. All right, now we're on to the best part about Looker, in my opinion, which are derived tables. Uh, now let's finally learn about derived tables. So far, with the tables that we've been working with, they've already existed inside of the database, but sometimes the dimensionality, the structure of the table is not exactly how you want it. You need to do some data wrangling, some manipulation to the data. Um, that's where derived tables come into play. A derived table is basically a table that you create off of a pre-existing table in the database. So here's an example of a derived table being used. A derived table typically gets used by using a CTE. You know something is a CTE if it has the with statement in front of it. Um, so a derived table will allow us to transform a measure into dimension so that we can do it for the next step of the aggregation. Let me show you some examples. Yeah, derived tables are very helpful. Sometimes you got to do something wrangling with the data that you just can't do in LookML, such as like the union statement, um, or applying window functions. Um, show some examples of derived table. Let's go to the Phoenix project. I'll show you some derived tables. So here's an example of a basic SQL derived table.
Could you please zoom in a bit?
Of course. So a derived table is created in a view file, and it has the term derived table in it. And basically, this is the SQL query of the derived table right here. And it functions just like a normal view would, and that, you define the derived table and then you supplement the dimensions and the measures and all that below it. This is what is known as a SQL derived table because, well, the other option is a native derived table, and I'll show you that shortly. But sometimes you need to do data wrangling on the table to get it into a different structure, and that's what a derived table will do, like you see here. Now the other option is a native derived table, which is very different than a SQL derived table. This is what is known as a native derived table. It recycles the code from a pre-existing Explore definition. You can see this isn't SQL that is in the derived table statement, but it's basically just referencing an Explore source, as you see here, and then it's just supplementing what fields you want to do. Yeah, this is, when to use SQL derived tables, when to use native derived tables. It takes some experience to understand when to use each one. If you got to do something really crazy in SQL, you want to use a SQL derived table. In this example, if you want filters to persist into this derived table, something you can't do in a SQL derived table, but you can do in a native derived table, then that's the time to use a native derived table. In order to create any drive table, I'll give you an example of how to do that. So here's an example of a so I haven't shown you this yet, but there's something called SQL Runner, and this allows you to just write SQL to off your database. So it's just, you get this in your database, whether it be BigQuery or Snowflake. This just allows you to write SQL like like you're just writing SQL in your database. If I run this is really where the kitchen is when it comes to building a drive table. You're going to want to go into SQL Runner and build out the query exactly in SQL Runner. And that's what I'm doing right here. It's running. Hopefully, once this ends, it'll show up. But once you create the SQL, you can quickly turn it into a derived table LookML just by going to the gear icon and clicking this button. So we just created a SQL query right here. And if we want to turn it into a derived table, here are the results of the query. If we want to turn it into a derived table, we go to get derived table LookML. And here is all the exact LookML for this drive table. It provides all of the syntax, and below it even defines all of the dimensions. So it does all the work for you. You just basically copy this and you go into your project. You would create a new view, create view right here, and then you would just paste it in. I'm not going to paste it in because this is a live project. So just to reiterate, derived tables are manually written or produced select statements where the result set can be queried just like a real database table. They are integrated in LookML projects and views. We can explore and join those views, same as views pointing to real database tables. Derived tables can either be ephemeral or persistent. Ephemeral meaning it doesn't have any caching on it. It's never getting saved off. Persistent meaning that it is being cached. It does have it is being saved off to the database in order to save on database load and query time. So the big benefit of a persistent drive table is that they're always ready to go when the business needs them. The downside is that it takes up storage space, or if you need that data to like be live to the second, then you're not going to want to persist it. You're going to always want it to be ephemeral. There's two types of derived tables. I showed you those two examples. There's SQL derived tables and there's native derived tables. SQL derived tables tend to be pretty simple to learn. If you know SQL, you're going to be able to know how to create a SQL derived table. Native derived tables, on the other hand, have its own type of code that you're going to have to get used to, but it certainly has some major benefits. One being maximum code reusability. They're easier to maintain, and they have some special things that you can do that you can't do in a SQL drive table. All right, we're about out of time. So I wish I got to go more into derived tables, but we're out of time, and I hope you guys, gained a lot of knowledge about Looker over these past 3 days. If you have any questions, please reach out to me. I'm more than happy to help. My intention is just to grow our Looker capabilities as a company. So for any of you really wanting to learn Looker, please reach out to me and I'll be happy to help you out along the way. Don't forget about those skills badges. That's a great way to learn. We already have some people already getting those badges. I'm going to be getting them in the next week or two. That's a great way to learn it. And then, keep in mind the Looker documentation folder that I've sent you guys. There's 3 boot camp slide decks that are probably the best piece of learning material for Looker that I strongly recommend that you just read through on your own in order to get the knowledge that you need. So thank you all for your time. Thank you all for attending. Have a good rest of your day.
Thank you,
Thank you,
Danny.
Danny.
Thank you.
Thank you.
Thank you.